This conference will now be recorded.
Okay, how's that?
That is much better.
All right, great. Thanks, Michael. Something about my settings on my computer, every now and then it just goes really faint with no explanation, and it does not fix itself until I restart. So, all right, thanks for your patience. We have a full meeting today, so I will go ahead and get started. Before we go into the agenda, I sent out in the email, Data Center World has a open call for proposals. I believe the deadline is February 15th, and the conference is in August of next year, live in Orlando, but I believe there'll also be a virtual component of that. So it was brought to me in the context of open compute. So if anybody has a open compute topic that they'd be interested in discussing and need support from either the sub-projects or any of the work streams or the foundation itself, the offer is out there to help anybody in the interest of supporting an OCP-related cause. And I have already put on the agenda for January 17th, which is the next data center facilities meeting. And we'll have some time there for open discussion. So if anybody has any topic ideas or anything that they're working on submitting, there will be time at that meeting. In the meantime, or after that, if there's anything I can do or the foundation can do, feel free to reach out, and we'll see what we can do to help. And
Hey,
then
Rob,
we have,
this is
Yep.
Archana. I was going to just make one more point to the same comment that you made around Data Center World. If there are conferences out there that the team here feels that OCP should be represented at and is not, please let us know. Obviously, we can't be everywhere all the time, but we're going to lean on our volunteer leaders and our communities to help us broaden the scope of OCP, as well as look at sister organizations that we should be participating in and partnering with. So if there's conferences that we're missing or venues that we're missing, please let us know. Bring it to my attention, bring it to Michael Schill's attention, or any of the project leads here, and we'll be happy to look into them too. So that's it.
Excellent. Thank you, Archana. And then we have some roles transitioning coming up, and our IC representative, Brevin Rayner, who was the data center facility lead, then moved over to the IC, has an update for us. So I'll let Brevin take the floor.
Yes, thank you, Rob. So I have a bit of announcement for the group here. As some of you may or may not know, I have moved on from Rackspace Technology. And with that, regretfully, that also means I must step down as the IC representative for the Data Center Facility Group. We don't currently know who's going to replace me or what that looks like, but I have high confidence in Rob and Anand to go ahead and, continue to lead the group as the project co-lead until a replacement is found. Just for everybody, on a personal note, I've immensely enjoyed working with you guys and leading this project. You guys coming in and being so open and collaborative, it really it was really good to see and good to be a part of. So I appreciate everything that you guys have done. I'm still going to remain involved. I just won't be a part of the leadership team anymore. So thank you very much.
Thank you, Brevin. You will surely be missed as your role as IC representative, but I'm certain you won't stay too far from the OCP, I would imagine.
Oh, there's no way. We will make sure that he is roped back in and that we're leaning on him every chance we get. So you can't stray too far away from us, Brevin.
It's a small industry. We know. You know where to find me.
Yeah, we do.
Yes, we do.
And then thanks, Brevin, and certainly I appreciate all the involvement you've had in getting me involved with the OCP, and it's been great. So you'll surely be missed in the role, and we wish you luck on your future endeavor. And I do want to go through
Thank you, Brevin,
our
for
sub-project. Anand, before I go into the sub-projects, is there any topics or updates you want to offer the group? Maybe related to security?
No, go right ahead. I can sort of wrap up at the end with security and monitoring. Sorry to interrupt.
Oh, no problem. Bob Oliver, are you on the call? I think Bob had a conflict at this meeting time. I don't see him on here. So if he joins back in, we'll give him the floor for MDC sub-project update, and I can give a brief one. We had a discussion just last week. We had good attendance at the last MDC sub-project meeting, and there's discussions around the next work streams related to updating the specification and working on a couple other items related to modular data centers. And so I know that is going to be the top of the discussion at their next meeting in January. So I encourage anybody interested in the modular data center arena to join that call because it'd be an opportunity to influence or bring up questions around the OCP spec and really open some doors. It's been somewhat restrictive, and hopefully garner some more interest and contributions to the MDC project. And I know there's a couple new people that have interest in the MDC project for some contributions. So there's been somewhat of a plateau since the last contributions in that group, but I think it's really getting ready to get moving again. So I encourage you, if you have interest, please join that call. Mark, on the OCP Ready front.
Okay, thanks, Rob. So the final draft of the Code of Facility Guidelines for deployment of open racks was completed sort of this week. Had some final sort of edits that came from Stein. So thanks, Stein, for your input on getting the document as close to as good as we can get. So really, it's sort of the final sort of draft and out for comment was finishing today. Unless if there's anyone on the call who would like to sort of make any comments or suggestions to changes in the document before it's published, then please shout out. But but I think, Rob, if we don't hear from anyone on the call that needs to make some suggestions, then I think we're ready to publish. So anyone on the call had any questions or comments to make about the guidelines?
I think it's a great document, Mark. Great contributions were made, what I saw. So, yeah, good.
Yeah, thanks, Stein. Yeah, you've been a great help with it. Really, really great help. So
we need to probably
Rob,
present. Yeah, we probably need to present that to the IC.
that was my next question. Yeah, do we need to? So obviously, this first time we revised the document. Do we need to go through the approval process again?
I think we should.
Okay. Okay.
Yeah, I think it accomplishes two things. One is that it lets the entire IC know what you've been up to, and also kind of broadcasts the fact that we're ready. You know, no pun intended, but we are OCP ready now. And I think that that's probably a really good thing for all of the IC to hear, and also then take back to their individual groups. And, you know, if there's interest there, then they can socialize it there, or Mark, you and the team can come back and, you know, present to, say, the Rack and Power group, if there's a lot of interest there, or maybe the Telco Edge group, if there's a lot of interest there. So I think that, you know, presenting to the IC can't hurt.
Okay. Yeah. No, I think you're you're spot on there. Yeah, certainly widens the you know, the as you say, socializes it throughout the community, and sort of widens the spread of information, because yeah, so much going on in the OCP community. Then you know, sometimes some of these things do get lost in the you know, in everything else that's going on. So okay, that's great. Okay, so we'll do that, and on the on the sort of subject of any other facilities that are coming up for you know, to go through the recognition process. We don't have any definites at the moment. Still looking, I think, Q1 when we'll have the next facility looking for recognition. So yeah, that's all from me.
Thanks, Mark. It's been a busy year and some good things happening. So I'm excited to see the submission, and it's more than just OCP being OCP ready, being something. Is now that it's, you know, it's a stronger document in the reservation, that it, you know, has greater purpose. And so thanks for your contributions. And I think showing it to the IC, you know, I agree with Archana and Brevin's viewpoint, is that it's an enabling tool to get those other groups, their hardware, their projects into places and out and working. So I think it'd be great. So if I can help in any way as part of that discussion or that meeting, please let me know.
Great stuff.
Don Mitchell.
Well, hi. People went mute for a couple minutes. I didn't hear some of the conversation, and then y'all came back. So I may have missed something in the past couple words. So I'm going to be focusing the next couple downtime weeks, if you will, is how to transition to deliverables. And if there's anybody that has any free time to walk me through that, I don't. Good news is we've covered a lot of collection of information. I have a lot of participation from people. The issue of how to transition into deliverables and to more effectively share that with the community via the wiki is probably an area that I'm a little bit weak on. And yesterday we launched a demonstration of virtual design and construction, a BIM modeling, showing how simple and fast and clean it can be. A couple initiatives that we're looking at recommending would be the possibility that vendors supplying liquid cooled IT commit to modeling of that IT at a BIM LOD 400 level. What I have also found is the number of people on this call that know what BIM LOD 400 might be a limited number. However, if you understand the concept of modeling, dropping things into place, the ability to deploy liquids rapidly in data centers with a precision that would mimic, say, IKEA or Lego, is greatly enhanced. Modeling has to happen. If the vendors provide it, it accelerates and simplifies the world of construction and engineers. That's one area. The area of dew point control. Has that been, I thought I heard something like that. Is OCP taking a stance on dew point? Is the question understood? Is anybody hearing me?
I'm hearing you. I haven't heard any stance or discussion actually on dew point specifically.
So the point is,
would we do anything different than the ASHRAE standard?
so that's a great question, but what I would be saying, especially as we start looking at adding liquid cooling to the IT racks in a slab floor environment, which is kind of where most data centers are going, your piping is going to go overhead, okay? And a lot of the technologies that we're sponsoring with ACS operate at elevated temperature liquids. So the question would be door heat exchangers. The reason this ends up being a DCF discussion is that the design, your considerations for condensation are dramatically different if you know that the liquids going through your data center will be above dew point at all times. ASHRAE does not mandate that the liquids running through the data center are above dew point. They mandate that the temperature is maintained at a non-condensing environment for the equipment, but the historic method has been taking cool liquids, running them through and insulating them. And the negative on that is you can have cool liquids that are operating above dew point. Depends where you are and what the humidity content in your building is. If you know that every liquid in your building is above dew point, then the issue on condensate trays, the issue on condensate drains, the whole aspect of adding liquid cooling to a data center is greatly simplified. The number one cause of leaking pipes in data centers isn't leaking pipes. It's someone broke a vapor boundary and liquid condensed on the pipe. So this is not an ASHRAE issue. While ASHRAE does help give you the understanding of dew point and where it is a recommendation on people running liquids through data centers. Are we getting to the point where we would want to make that a guidance or requirement? And so if you're, let me rephrase that. If you're a rear door heat exchanger or cold plate, excuse me, if you're cold plate or immersion, you're fully on board with my discussion. You say there's no reason that our liquids ever need to be below 35 degree. So to that level, you can crank up the dew point. Or crank up the liquid temperature so it's clearly above dew point. It's kind of a complex question, I guess. To that extent, is it an ACF question, or is it a DCF question, or a bit of both?
Sounds like a bit of both.
So, I guess the question. So I'm going to be trying to not necessarily mandate it, but my understanding is what I go in with a D+ rating, where I basically introduce guidance with a this is desired and may become a requirement in 2 years kind of thing. It so simplifies deployment of if you don't put in or don't maintain your liquids well above dew point, then every pipe that goes over your racks should likely be insulated, and potentially you might have people that say, well, you need a drip tray underneath it. And if you have a drip tray, that seems simple enough, except for drip trays generally should have condensate drains, and condensate drains should have piping that takes it out. And you can see how this steamrolls into to a much more complex process than just leaving room for your pipe.
So there's a longer discussion. We should discuss this in more detail because the whole point of the non-condensing verbiage in the ASHRAE spec is precisely for this reason. I do agree that you're pointing out that this is a somewhat different use case than what ASHRAE has been sort of used to, but I'm not so sure you need an explicit dew point specification because ultimately it is a sort of complex interaction, as you pointed out, between the relative humidity in the data center and the temperature that the liquid is actually that the liquid is actually at, as well as ambient temperatures and so on. So I think we should have a longer discussion about it. I'm not so sure you need an explicit definition.
Okay, so the kind of the different spin on this is putting it on the data center owner's responsibility. And I've heard, the stories I've heard are people adding rear door heat exchangers, not anticipating that the liquid in the rear door heat exchanger, that some section of pipe, not the big pipe, but maybe the little piece of pipe that goes down to the IT rack, starts collecting, is operating below dew point. Not that the data center is outside of ASHRAE guidance, but that the temperature of that pipe is now below dew point. And so what ended up happening was they started having condensate issues. To address those condensate issues, they bumped up their operating temperature just a bit. And when they bumped up their operating temperature of the data center just a bit, although it was still within ASHRAE guidance, they found they had SLA conflicts, okay? So the concept of looking at this is a different way of looking at data centers than historically, at dew point, than it's historically been done. People have always assumed that liquids would likely be below dew point, and they've designed their liquid distribution accordingly with insulation and things of that nature, and condensate trays and stuff like that. We are getting to a point that many data centers don't have to. So if the ACF guidance might be something to the effect of, if you are planning on putting in liquid cooled, considerations need to be made whether or not you are going to maintain either the data center humidity or the liquid temperature at levels that will avoid dew point consideration, because this design guidance being provided.
So Don, in the interest of time, I'm definitely agreeing that we need more discussion. I'm just not convinced that the solution is to have an explicit dew point spec. So perhaps we have a longer discussion in the ACF forum around this to kind of figure out what the best approach is.
So how would I act on that? How would you want me to, in the ACF forum or in the DCF forum?
Maybe start with the ACF forum. You're likely going to have a more focused attendance there, and then we can sort of bubble that up to the DCF forum based on what the results of that discussion are.
We've had some discussion in the ACF forum. I'm probably going to take it to my steering committee, if you will, in that area, as we look at other aspects of the DCF side. That's where I was going over. Outside of that, transitioning other points, is there anyone who wants to work with me on improving my performance on contributing to DCF?
I'd be interested in jumping in on the ACF discussion and this dew point discussion specifically, and any of the other contributions you have going on. I mean, I fumbled through it to some extent with a lot of help from other people on, the wiki and the other things. So I'd be happy to jump in on the next call and see if I can help kind of figure out the next steps, and I'd be happy to help you with that.
Fair enough. So one other area that would also impact DCF would be whether or not you're going to say if a data center owner needs to reserve space. There are data centers, I've talked to people that have designed data centers where if they're going to add liquids, they would maintain a design space for pipe distribution in the vertical that is clear and flowing. Is that something that goes back to the DCF design, or is that something that I keep on the ACF side? Does the question even make sense?
I follow you. My experience has been when a sub-project has something that's driving a change that may need visibility from the broader DCF, is that someone has come up with, here's the problem, here's our proposal, and then the question gets presented to the group of, does this affect anything else that we're not looking at? And does anybody have input on it? But it's somewhat pulled together before we bring to the DCF community, just because there's so many people of different subject matters that are in there, that it needs to be a little more concrete before bringing to this group to be effective. Otherwise, we end up talking about it and then nothing actually happens. Does that make sense? Or did you freeze on me? No. Don's either a picture now or he's frozen. Does that make sense to anybody else? Does anybody else have any thoughts on that process from coming from a sub-project up to data center facility? All right, we'll see if Don rejoins us. But in the interest of time, I do want to get to, we have two guest presenters that asked for some time here, and I would like to get to them. First is David, who has a presentation on MDC cooling. And David, could you do me a favor and pronouncing your last name?
You hear me?
Yes.
My surname is Gül Nazaryan. Gül Nazaryan.
Excellent, thank you. Let me find you. There's so many tiles on our meeting today, so I have to find yours and make you the presenter if you'd like to share your screen.
Yes, please.
I'm back.
Okay, you are the presenter.
Okay. So you see the screen?
Yes, and the floor is all yours. So if you wouldn't mind, if you give us a little intro on what you're about to show us, and then I've already gone through your presentation. It's very good, and I'd like to learn more about it, and then open the floor up to questions afterwards. And then we have one more presentation after this before our meeting agenda is closed today. So take it away, David. Thank you.
Thanks. So I will start, dear colleagues. Today, it's obvious that the data center industry will continue to actively develop, but in the conditions of global crisis, more reliable solutions with low capex and opex will be in demand. In our presentation, we will tell you how to create the conditions for sustainable development of the OCP modular data center. So for more than a century, we have been providing solutions to maintain the necessary conditions in various fields, from cooling diesel engines to greenhouses for growing vegetables. And as experts, we receive requests for reliable, high quality, and simple solution for cooling the data center. As a result, those who have turned to us got a solution that fully satisfied their needs. We know about the problem of overheating zones, the high cost of building of data center, the requirement for high degree of reliability and redundancy, and the desire of each owner of a commercial data center to minimize operating cost. And there is 4 scenarios. In the classic version of the data center cooling with crack, in-row, air-to-air system or cold wall, in most cases, the real power does not reach the calculated capacity, because to cool down the air is not meant to cool down the servers. There is no guarantee from cooling unit producer that everything will be work as you wish, and the operational service of each data center is involved in endless process of balancing airflows. And the server racks with powerful servers are half full or less. The owner of data center is losing money due to an efficient engineering infrastructure. In case with backdoor cooling, we can increase the rack capacity up to 30 kilowatts, but we are faced with low capacity of heat exchangers in itself. And for that reason, we need low temperature of liquid with high flow rate, which decrease the free cooling time and significant increase pump's energy consumption. Regarding price, it is more expensive as we need to use reliable connections. With HPC, the capacity per rack grow up to 90 kilowatt, and we don't use the fans for air circulation, but the technology even more expensive than previous as there are much more connections. But we have an important advantage as the high temperature of cooling liquid, which means round-year free cooling and even waste heat using in district heating. And one of most efficient cooling solution today had two important issues which limited their grabbing the market. And they are is the price and service. I mean, if you need to change components, memory stick, SSD, and etc. in 200 units, air cooling servers, by the time it will be much convenient and faster than an immersed server. But there is another two options which I want to describe to you now. Low speed ventilation. It's a solution which supply the air in the amount of servers, and it fully satisfied for all kinds of servers and gives us possibility to work even with high temperature air because there is no mixed air from hot and cold corridor. And the uniqueness of this solution is that the control is dedicated by the servers. And second thing is loop heat pipe is alternative to the HPC, but there is no liquid. It is closed circuit with passive heat transfer. So we recommend option E because industrial low-speed ventilation air coolers are designed according to the needs of the servers, and due to large cross-section and large heat exchange area, they provide clear cooling capacity over entire load range without condensate and extremely low power consumption of fans. The LSV design provides for the operation of the server room and coolers as a whole. Therefore, there are no bottlenecks, weaknesses. The large cross-section of the coolers gives a low uniform airflow rate along the entire path with a resistance of less than 30 Pascal. Which creates conditions for the absence of pressure drops that could lead to appearance of the Venturi effect and overheating zones. On the other hand, it is an opportunity to work without overpressure to drastically reduce the power of fans and their heat dissipation. In all existing LSV data center, service staff are not aware of problems with overheating zones. You see CFD modeling, which was carried out by our customer for a hall with 48 racks with an average power of 28 kilowatts, which proves the ability of low-speed ventilation to work with high-density racks. There is also a solution with loop heat pipe that allows you to remove up to 500 watts from one processor. When placed in a single rack, 40 servers, like with these processors, and 4 processors in each server, we can remove from one rack 80 kilowatts using LHP and another 10 kilowatt using air cooling. I will talk more about this solution later. So you can see the extremely low power consumption of LSV fans, and the use of innovative adiabatic coolers can increase the useful share of IT light up to 85%. So the point is that we can really decrease the energy consumption of our system per year according to less and less energy consumption for the cooling systems. And also the ratio of input power is also go down because the cooling system in itself is consumed much less because we use higher temperatures for cooling for liquid, and in the third case we don't need even a chiller, and this not work with conventional solution because there is a risk of overheating. For that reason we need always low temperature. But in next example, I will show that we can work with the same servers with 30 degrees air in cold aisle and no problem at all. And this is the total cost of data centers. If we compare the conventional solution, crack-based solution, the average price of data center building is from 15 till 30 million per megawatt. I take the average, and it's 22.5. And in percentage, if you compare LSV based solution and LSV with adiabatic coolers and LHP, it goes down. That's the trend which I want to show, that the data center will be more efficient, less in price, and that's the market demand. Another thing is the hot fluid temperature, which we get from our cooling units. In case with LSV, it can go up to 32 degrees, and it can be used for some ground heating or greenhouses. And Tercon LHP can achieve higher temperature, which can be used in district heating without using heat pumps. So a few words about LHP. LHP is a passive loop heat pipe with which heated up by processor, and itself transfer the energy to the end of rack where is installed the passive heat sink, and through it going the liquid with high temperatures. By the way, when we decrease the quantity of the fan servers, IT load is reduced by 5–10%. And if we compare all existing solutions for OCP modular data center, we see that this last two solution is attractive by lower energy consumption for the fans, more energy capacity per rack. You can easily install up to 30 degrees air-cooled racks, and the most important thing for LSV is that we deliver air according to servers demand. The LSV consumption is measure the airflow which created by servers, and we deliver exactly that amount of air. And there is no bottleneck, so it can work without hotspots, which allows us use high temperatures of air to cool down the servers. So when our client is happy, the happier also the end users. So I just want to show some examples where we realize our solutions. and one of them is a client in Kazakhstan. They use low-speed ventilation without any chiller, so just adiabatic cooler. This is the room, and through the test this year, we go through the 32 degrees outside air temperature, ambient air, and we cool down the racks with 27, 28 degrees air in cold dial. This is the plan of this data center. It's not so big, it's small, and there is 3 coolers. You see some of them, and energy consumption of coolers is very low. So average for the year PUE is 1.075, which whereas 5% only goes to UPS system. And this is outside adiabatic coolers. And you see that at +5, the fans is turned off. It means that at +4, it works in a passive way without fan using. So this is the key for low energy consumption. Another data center in Moscow, Data Pro. There was a realized data center with LHP system. Here you see the back of the rack where dry connection for the LHP and no any liquid into the servers, only in the back of rack. And also there is redundancy, 1 inlet, 2 inlets and 2 outlets. And the tests show that servers without fans with LHP is reduced energy consumption by 15%. And the last example is BytosNet. It's a collocation company, one of their data center in Rotterdam, Netherlands, with crack units, and second one they built with LSV in Groningen. And they reduce the capex. They don't use raised floor. In the end of this corridor, you see the LSV. It is outside of the white space. The fans rotating are with low speed. It means they run long lifetime up to 30 years, and PUE with chillers, here we use chillers, is 1.10. They use dry coolers. When we have possibility to use only free cooling, we use only dry coolers. If they are not enough, we start to cool down after dry cooler by chiller. And at the hot period, when the peak of the outside temperature, we use just chillers. And also for UPS cooling, it's possible to use such kind of coolers, which just connected to the top and reduce the space for UPS cooling. So if you want to know more, you can ask me, and I provide the design of the data center, which will be made according to low speed ventilation, and also all other components to get the best result. Thanks for your attention.
David, thank you. I'll open it to the floor. Does anybody have any questions or comments?
Yes. But no questions. There is just
I dropped off during the presentation once or twice, but I was very interested in a lot of the discussions. If you could send me an email, or I'll send you an email, I guess, I see you're on LinkedIn as well. I've worked with many of the technologies you're talking about. Just what is the objective that you're trying to get right now, I guess is another question.
Sorry, could you repeat, please?
The purpose, what are we seeking to do in this discussion today? What's the next step that you want from this program?
The next step is to create the same rules without bottlenecks for air cooling of OCP modular data center. The aim is to implement that rules which give to OCP modular data center work without overpressure, without hotspots, and have possibility to work with air-cooled chillers, but up to 30-40 kilowatts per rack. This is the driver which why the people move from air-cooled server to immersion cooling or high-performance cooling.
So the liquid heat pipe, your liquid heat pipe is contained by the servers?
Liquid LHP, you mean a loop heat pipe?
Yes.
Loop heat pipe, it's closed loop. It without any water inside it of it. It transfer the heat from the processor to the end of rack in passive way, so it's dry and so.
But there's a liquid loop inside the server. It's a self-contained capillary loop with a two-phase transition.
Yes, yes. There is used different kind of ammonia.
The condenser plate that takes the heat from the backside of that loop out the is that a common product, or is that a proprietary product?
Actually, it was made with the partner, which name is Tercon, thermal contact in short, Tercon, and they work with different server producer. So they produce these heat pipes, which implemented in each kind of server. So it's integrated solution.
So again, we'll take it offline. I don't want to dominate it. I worked with Intel back in 2004 on a liquid heat pipe solution, and the breakdown of that was the to a large extent the condenser plate on the backside. So you have a way of taking the heat off the chip, but then it goes to a condenser plate, and somehow connecting the condenser plate to a way of transporting the heat out of the building was a variable that wasn't easily answered. But again, I don't want to go deep dive here. Don Mitchell, you can ping on me at donmitchell.ocp or the OCP email address, and I'll take a look at it.
Yes, this is the photos. You can see that there is dry lock, dry contact in the end. So that's how it's worked.
David, thank you. What I'll do in the interest of time is I'll make sure that you and Don are connected on the cooling side, so you guys can continue the conversation. And then I'm happy to stay connected. And if you have interest in the modular data center group, and please continue some of this, or the cooling group, then we'll make sure you're connected to the right people that have the most interest in this. Okay. All right, anybody else has any questions, feel free to reply to the mailing list or to me, and I will make sure that if you didn't grab David's email address, I will make sure that he gets them.
So I can stop sharing?
Yes, please. We have one more presentation today. Thank you all for sticking on. Karush Namansi, are you on? I see you're linked here. Can you hear me okay?
Rob, hi.
Hi, Rob.
Yeah, and this is Sherman Ikimoto from Future Facilities also. I'm going to be presenting with Kurush. If you, we'll start with my screen. If you can share
Sure.
the sharing feature, and then we'll switch over to Kurush.
All right. Well, thank you both gentlemen from Future Facilities for joining our call today. And you should have a presentation mode there, and I will let you guys have the floor. Thank you.
All right. Thank you, Rob. I think I shared the wrong screen.
Happens to me all the time.
Okay. Okay. Do you see a Future Facilities slide?
Yes. Yes.
Okay. It seems like there's quite a delay, so I'll try to be aware of the delay. Good morning, good afternoon, everyone. My name is Sherman Ikimoto. I'm a managing director at Future Facilities, and with me is Kurush Namanti. He's our research manager at Future Facilities. I'm located in San Jose, California, and Kurush is in Arizona. And what we were hoping to accomplish today was to introduce to the open compute audience the concept of digital twin. We'll go into that in some detail, and then how digital twin might help open compute to develop and advance the open compute hardware technologies and standards that are under development at the moment. So just a quick introduction to the company. We're a privately owned software company. We also provide services. We are experts in engineering simulation, especially in the area of computational fluid dynamics. Our focus is to apply these technologies to the concept of digital twin, again, which we'll go into. And what we're trying to achieve in the industry is to enable all data centers to realize their business potential. And again, we'll explain that in more detail in the presentation. Our mission is to deliver a digital twin for every data center, and also to organize and connect the data center ecosystem through simulation. So the concept of digital twin is actually not new. It was introduced almost 20 years ago by a professor at the University of Michigan as a new approach to product lifecycle management. And what a digital twin is a replica of a physical product or system that exists in virtual space on the computer. And digital twins look and behave like their physical counterparts. And these characteristics are used to understand and optimize the performance of physical systems. And this could happen in design, development, or also in operation of a physical system. And digital twins today are used quite a bit in many industries, including aerospace, automotive, energy, manufacturing. And what we are introducing today is the concept of digital twin for data centers. So this is a digital twin. We're walking through one, and up in the upper right is its physical counterpart, so that you can see visually how similar they are. One, of course, in the virtual world, one in the physical world. So digital twin is your data center that has been replicated in a virtual world. And it's where stakeholders from all corners of the data center design or the operations teams go to plan the implementation of changes or to optimize performance at various levels in the data center system. So on the surface, digital twin looks very similar to a DCIM tool, but in addition to DCIM functionality, digital twin has a physics-based simulation capability built in to mimic the airflow delivery, the cooling system performance, the power distribution, performance under normal and failure operating scenarios. All that can be simulated in a digital twin. And digital twin is made up of two parts, a 3D data model and a physics-based simulation capability. And this brings a new capability to the data center industry that we call computational data center design and management. So in the management of data centers currently, the management practices or the processes are broken up into silos, usually along lines of expertise, such as networking, space, power, cooling. And as a result, data center performance is optimized for the highest priority silo. It could be networking, that's common, or space or power. And it's optimized at the highest priority silos at the expense of the other silos and also at the expense of data center performance overall. Digital twin elevates the focus of data center design and management from the performance of silos to the performance of the data center system in its entirety. Now, current design and manufacturing practices, they're also split between levels of integration. Here we see two levels, the components of a data center and the data center facility. And a lot of effort is put into optimizing the performance at the level of these systems or at the level of the data center facility, but not combined. And so what digital twin does is it encompasses both levels of integration to provide an understanding of how the combination of IT configurations and facilities perform as a unit. So let me just go into a quick example of this. So here we have a data center and we want to make a change. We're going to add 3 high density IT racks to this data center. And these IT units were designed, of course, separate from the facility that it's going to go into and designed to performance specs that are different to what the data center was designed to support. So this raises questions. What will be the combined performance impact? And can the combined impact be optimized? So today, change requests are addressed by applying simple guidelines or best practices that are based on generic design or planning scenarios. And in our example, these guidelines would likely produce this configuration that you see on the screen. However, if we were nervous about environmental compliance, we might spread the units out and add more floor grills or more cooling to those 3 racks just to be safe. Or if we wanted to aggressively conserve resources, we might choose this more compact configuration for the 3 racks. But here's the problem. Today's data center management tools and techniques are blind to the performance impact of this integration between IT and the facility. So one of these configurations is the best, but we don't know which one. And this is a cloud of uncertainty that hangs over the head of every data center operator, which leads to service delivery delays, environmental risk, and inefficient use of the data center. So if we return to the example and use digital twin to simulate this impact, we can see the difference. So we run a simulation and immediately digital twin reveals something that we didn't know before. Option 1 will fail compliance by overheating IT racks that were already up and running in the data center. And digital twin's ability to mimic physical behavior helps us to avoid this or helps us to see it first and to avoid this a compliance disaster. So we saw the CFD capability being used to reveal the source of a cooling problem. And it also, digital twin also provides the foresight that we need to design a solution. So we added a new cooling unit to eliminate this violation. But the result of that solution is an unexpectedly high cost to implement those 3 racks after accounting for the cost impact of having to add a new cooling unit. We can also evaluate the conservative option. This option works without having to upgrade the infrastructure, without having to add anything, But this option is costly because it will use 25% more space and 16% more airflow than option 1. And we can also evaluate the aggressive option. Option 3 will also meet compliance without an infrastructure upgrade. And this is an unexpected result because best practices gut feel says that 20 kilowatt racks cannot be placed this close together without causing a compliance problem. So to summarize, in terms of compliance, all 3 options will pass, but option 1 would require an infrastructure upgrade first. In terms of costs, resource costs, other costs, option 3, the aggressive option, is by far the most cost-effective across the board. And it also will enable the fastest and easiest service delivery. So what we wanted to illustrate here is that by using digital twin, we can design across levels of integration to see the system level impact of design options, operational changes, moves, adds, and changes of IT equipment. But there's more. Digital twin is also a part of a larger industry scale digital ecosystem. So this concept, this digital twin concept, encompasses virtual design at all levels of integration, including IT systems, infrastructure components, and also the bare facility as well. And in the process of designing these components, the final output of these designs are digital twins that are the building blocks of the next level of integration, which is the data center. So this concept is meant to be applied across the entire ecosystem for design of the components and to allow the component manufacturers, the IT systems manufacturers to design without having to worry about the final application to optimize at their system level, but then provide a way to integrate all of these components at the next level of integration, the data center, and optimize performance at that level as well. So this digital ecosystem, again, covers all levels of design integration. We saw from system to facility, but it actually covers levels of integration from the chip to the chiller across all scales. So I'm going to turn over to Kurush now to show you how this digital twin concept is applied at the smaller scales from chip to system.
Okay, cool.
Kurush, are you able to take control now?
Sure. If I can share my screen. Great. Can you guys see the screen?
Yes.
Awesome. Okay, cool. Yeah, hey everyone. This is Kurush Nemeti. I am a research manager at Future Facilities. So based on what we've heard from Sherman is basically we are using digital twin for design and operate a data center from different levels, from server level to the cabinet level to all the way to the facility level. We are using digital twin, but what I am going to show here is just like a case study that we have done that is kind of illustrating how important it is to use a single platform to model the entire supply chain, basically going all the way from chip to chiller in a single platform, because we have seen that when we are using different platforms during exchanging data between the platforms, we are losing a lot of important data, and it's hard to share the data between different platforms. So here we are, I'm going to show kind of a complex system, which is a hybrid cooled data center. It has liquid cooling and air cooling, and showing how using digital twin can help us to understand our data center in a better way. So we started with modeling a detailed model of a cold plate, and we use a detailed 3D CAD model of these cold plates to analyze them in the 3D environment in the software. Basically, with using the software, we don't need it to kind of make a first prototype of our cold plate and start doing experimental analysis on it. We can get all the information from the digital twin model of them. You can see that we get the PQ curve and the thermal resistance curve from for these two cold plates, and we can compare them and see what's the effect of using each of them in our data center. So we put this cold plate model in a detailed chassis model that you can see. This is a 2U box that it has 6 liquid-cooled GPUs and 2 air-cooled CPUs. And you can see that we connected the cold plates to the supply and return manifold using a detailed pipe model. So we analyzed this server, and we went through different type of analysis. And we all know that when we are designing a hybrid cooled system, one important parameter that is nowadays that everybody is talking about is heat capture ratio, and that is the ratio of the heat that is being removed by liquid. So you can see that we have done some analysis and show how increasing the airflow is decreasing the heat capture ratio. So it means a higher portion of the heat is being removed by air. We get the impedance curve, which is a representative of the physical area of the chassis, and we put this. Now we can use this data to go ahead and do further analysis in rack level and room level without using this much detail in our CFD model. So we haven't stopped here. We went one step further because we wanted to make a simplification to our model. So we replaced the detailed cold plate models with a simplified cold plate models, as you can see in the picture on the bottom left. And we replaced the entire cooling system, the liquid on the liquid side, with a 1D flow network that you can see in the picture on the top right. Basically, this is an innovative way to model the liquid cooling. Basically, we are getting all the detailed information from the CFD model on the air side, and we are getting the information on the liquid side, and we do this simulation together. That's why we call it as a co-simulation. So this is exactly where what I was talking about, that we use a single platform that can do both liquid cooling analysis and air cooling analysis simultaneously. So you can what you can see here is on the flow network, you can see the supply manifold in the middle that is delivering liquid to cold plates. That's our purple boxes on the bottom, and that is the connection between the 1D environment and the 3D environment. and then the warmer liquid is going through the return manifold. So we put 30 of these chassis in a air-cooled rack. So these are passive chassis. It doesn't have fans inside the chassis. So the cabinet has 4 rear door fans. You can see in the picture. And then on the liquid side, we use the 1D flow network, as you can see in the picture. So the supply manifold on the left-hand side is delivering air to the supply quick disconnects, which is connected to IT equipment. That's the purple boxes in the middle, and then the liquid is going through the return quick disconnect and then the return manifold, and that's where the flow is going back to the system. So we put 8 of these cabinets beside each other, and we made a row of the cabinets. And on the air side, we put 6 pro gears or prophetic tiles in front of these cabinets. And on the liquid side, we connected all these cabinets to the CDU objects that you can see in the picture. Also, the CDU object is made of 2 parts. That is a liquid-to-liquid heat exchanger on one part, and a pump, a controllable pump that can be controlled based on the temperature or flow rate that is desired to be delivered to the cabinet. So in the picture on the bottom right, you can see the flow network for this entire row, and the boxes in the middle are representative of the cabinets. And in the software, double clicking on each of the boxes is bringing us to the flow network that we have seen in the previous page for each cabinet. So this is helping us to keep our flow network very simple and easy to understand and easy to look at the results. And then we put 8 of these cabinets in a row that it has 10 ACUs and a chilled water system that is providing chilled water for both ACUs and CDUs. And in the flow network, you can see that the smaller purple boxes are representative of ACUs, and bigger boxes are representative of CDUs. So with combining this, we can get information about the water usage, and we can define our control systems in a way that we can deliver enough liquid or enough fresh water to our ACUs and to the CDUs. It's worth to mention that in this room, we powered off 4 of the ACUs to be able to save the energy. And then we did some quick analysis using this model. On the bottom left, you can see the analysis that we can do on the air side, and rest of the page is showing our liquid side analysis starting from room level, going to row level, and then cabinet level. Also, we can look at the IT level. So this picture is showing something very important to us. That is why we are doing this co-simulation. On the 3D environment, we are seeing some recirculation that is happening in the room that is only can be captured from a 3D analysis. You can see some of the rows that are drawing air from their own exhaust, and this is causing elevated temperature at their inlet. And then on the liquid side, we are seeing all the information from the pressure drop that is happening and in the pipes, in the quick disconnects, in the CDUs, and so on and so forth, and also all the temperature information we are getting. And then we did
I want to jump in here if you'd let me. We're running a bit over time of our normal meeting, and some people are I know have to run to other meetings. So I wanted to give anybody an opportunity to talk to you directly with any questions and connect with you. So
definitely.
Is anybody before they have to run? I want to open it up.
Yeah, can this presentation be shared, or it's really interesting? Stein here.
Real quick question in terms of digital twin modeling. Do you transition from construction modeling to operational modeling, or is it two separate developments?
Yeah.
No. Go ahead, Sam.
Oh yeah, sorry. Yeah, I was going to say that the concept does start in design, and then transition into operations as well.
So what I'm saying is design needs to go to an LOD 400 in order to get to construction grade fabrication level. Do you work in environments that can go to construction grade LOD 400?
I'm not familiar with that standard, but the data in the simulation model is optimized for simulation and not for producing, say, design information that can be based on that can be used to base construction on. So it is a separate workflow. There is integration though between the data that is used in design and simulation. Fair
enough. So I'm going to go offline, but I am very interested. What's one of the areas that we are looking at on the other side is the simplicity, and there's a BIM, or Building Information Management LOD level of determination standard that was introduced back in 2013 that helps people transition from your basic modeling to something that is construction grade. And it is the LOD 500 level actually integrates enough metadata that you should be able to do a lot of things. I've seen similar digital twin type environments done with that situation. So we'll just take it offline. If you want to reach out to me, Don Mitchell, I'd be more than happy to take a look at it. We are talking about this on the advanced cooling facility side. So
okay, thanks, Don. Thanks, Don. We'll make a note of that. Thank you.
And Sherman and Kurs, is this something that I could distribute to this community?
Yes.
Yes.
Okay, great.
Yeah, we'll send you links to download.
Yeah, either feel free to, I believe I copied you. If you're on the mailing list, you can respond to all. Or if you want to send it to me, and I can send it out, whichever you prefer. And Kurs, I'm sorry, I didn't mean to cut you off. If there was another point you wanted to make, I wanted to have it, but if there were questions before people had to run, I wanted to make sure that they had the opportunity to ask them.
No, actually that was kind of perfect timing. It was my last slide, and I was ready to wrap up. That was good.
Great.
Yeah.
Okay, great. There's a few people hanging on with us beyond time. Does anybody else have any other questions? Richard, actually, you had a question. Rich, you had a question early, I think, on an acronym there was WTF on the first presentation. Sherman, maybe that was on one of your slides.
WTF?
Yeah.
Geez, I'm not sure. What was it toward the end, or the
like waste heat flow, but or something like that? But the out of context, it means something totally different.
It might have been heat capture ratio in Kurish's presentation.
Yeah, then I read it totally wrong. I apologize.
Kurish, you want to take that question? Heat capture ratio?
Sure. What was the question?
Oh, just like the
what's HCR?
What does that mean?
Oh, so heat capture ratio is basically the amount of heat that is being removed by liquid over the total heat power generation. And we have done some analysis, and we got a correlation between the air flow rate, liquid flow rate, air temperature, and liquid temperature, and the power generation in CPUs and DIMMs and different parts in the chassis. That using digital twin can help you to understand these correlations, and you can get kind of accurate understanding of the heat capture ratio as different environments when you put your chassis in different environments with different temperature and different airflow delivery.
Cool, thank you.
Sure.
All right, thank you, gentlemen. I'll open the floor if anybody has anything else. You want to share the group before we close up for the day? I want to thank all our guests for presenting and everybody for attending for our last meeting of the year. I wish everybody a happy holidays. If you have any other thoughts or questions or want to connect with somebody in the group, feel free to send me an email, rob.coyle@ocproject.net, and or shoot out on the mailing list. Have a great day, everybody.
Thank you, Rob. Thank you.
Thanks, Mike.
Thanks.
Thank you. Goodbye.
Thank you and happy holidays to everyone. Bye-bye.